Hi, this is Mrs McTaggart. In this video we're going to look at the National 5 topic of quadratics, and we're going to be looking at specifically rocket style questions. So it's the quadratics in context where they put a story to it and ask you a variety of different manners. I am literally going to work through some of the past paper ones. These don't come up very often. It's generally every couple of years. Okay, so my first example is one part to it. They've given us the equation here which illustrates the profit made by a company. Y stands for the profit in pounds and X is the selling price in pence of the magazine. So to think about what's going on, why is the picture looking like a quadratic? If you keep your magazine really cheap, right? So if we have a really low price here, really cheap magazine, you're not going to make huge amounts of profit. So if you keep putting the price up a little bit, your profits will go up, won't they? But then at some point, if you make your magazine too expensive, you're not going to make much profit at all, so the profit goes down. So they need to find the perfect selling price for this to maximise profits. And that's illustrated by a quadratic. So to find the maximum profit they're going to make, they're essentially asking us to find our turning point. And to get the turning point, we have to find these values here, the roots. And the roots appear on the x-axis. They are both along something and up 0. So what we are going to do is we're going to replace y with 0. So we're going to put the equation equal to 0. Now sometimes you have to factorise this. It's already in factorised form to save us the effort. So we then break each bit up and put it equal to 0. So you've got 3x is 0 and you've got 120 take away x is 0. And from there, well, this is a common mistake here, by the way, 3x equals 0. A lot of people think x is 3 or minus 3. Remember, you're doing 0 divided by 3. And anytime you're doing 0 divided by anything, it's 0. Second one, I'm going to take the x to the other side. So I get 120 equals x, or written the other way around, x is 120. So what I've now worked out is that my roots appear at 0 and 120. So the midpoint of that is at 60. So I know that the turning point is along 60 up something. So I now have a value of x to substitute in. So I'm going to, into my equation, replace x with the number 60. And that will give me the profit. So y equals, you've got 3x in the equation, so you've got 3 times 60. And then in the bracket, you've got 120, take away 60. And if you work this out, 3 times 60 is 180. 120 take away 60 is 60. So I need to do basically 18 times 6. So 18 times 6, I like to go to 6. I don't want to make a mistake doing it mentally. Is 48. 6 times 1 is 6. Plus 4 is 108. So 10800. Now, y was my profit in pounds. So just to conclude the question, my maximum profit is, let's get rid of that. So maximum profit is 1080, and that is when the magazine costs 60p, but it doesn't ask for that, but it could. So that's when the magazine is at 60 pence. Now you might be thinking, oh, surely because you're talking in pence here, you need to divide by 100 to turn the profit into pounds. It's not. Remember the question said, y is the profit in pounds when x is in pence. So your final answer is correct. It is £10,800 for a profit. You're really not interested in a company that only makes £108 profit anyway. Right, let's look at another one. So this is just showing you a fancy way of asking you for the turning point, but they call it a maximum profit here or a maximum value. Question 2, this time we've got a rocket thrown into air. So when I talk about these questions, I talk about, rocket questions. So when you put a rocket into the air, it goes up and it comes back down. So it follows this kind of parabola-shaped trajectory. We've given the equation here in blue. First question says, how many seconds is the rocket in flight? So we know it starts when our time is 0. So we need to know when this rocket lands. We need to know when it lands, and then that way we'll know how long it's been up there for. So essentially it's asking you to find the roots, but it's worded funny. Remember, it doesn't come out outright and say find the roots of the equation. It's up to you to interpret that. So how do you find the roots? Well, your roots occur when your height is 0, so you replace height with 0. So I'm just going to put it on the right hand side though. So we've got negative 2t bracket t minus 14 equals 0. It's already in factorised form. So this bit gives us t is 0. Pull down this bit. That gives you, take the 14 over, it gives you t equals 14. So my root, which I've put there, is actually 14. So to answer the questions for part A, how long is the rocket in flight? Well, it sets off at a time of 0, lands at a time of 14, so it is in flight for 14 seconds. And I know it's seconds because it's said up here in the question, the height in metres after t seconds. Part B says, what is the maximum height reached by the rocket? Well, it's led you in, it's made you find the roots. Maximum height is asking what this value here is. So it's essentially asking you for the turning point again. So the turning point occurs in the middle of 0 and 14, which is 7. So we are going to replace our x coordinate with 7. Although this one isn't in terms of x, it's your t, okay? So this time we know it's along 7. We don't know what that is, but our x-axis is actually a t in this case. So our time is 7, so I'm replacing t with 7. So h equals negative 2 times 7. And then in the bracket, you've got 7 minus 14. Well, minus 2 times 7 is minus 14. 7 take away 14 is minus 7. So you've got minus 14 times minus 7, double negative turns positive. 14 times 7 is 98. And it was in metres, it says up here. So the maximum height reached by the rocket is 98 metres. And that occurs at 7 seconds. Again, it doesn't ask if I get that, but I'm putting it in anyway, just in case it did ask you that. Okay, so you need to watch out. It's not outwardly asking you what are the roots, what is the height, but just using your kind of understanding of the shape and the scenario, reading the question, can help you decide what you're actually doing here. Right, my third one's a wee bit different. This one's talking about a logo. So we've got this logo here for a capital A in the word artwork, and it's given by this equation in blue here, and we're showing a wee sketch of the parabola. We're told that the roots are labelled as Q and R, and it just says write down the coordinates of Q and R. So if we ask you to write something down, it means it's dead simple. Now Q and R are actually your roots, and they've already factorised this. So they've already factorised it and written it as this. So essentially I'm just putting that equal to 0. And when you put both these equations equal to 0, you get x equals positive 8, and you would get x equal to 2. So 2 would go with the q, because that's the lowest one on the left-hand side. So q would be 2, 0, and r would be the one on the right-hand side, which would be 8, 0. Remember, to write coordinates, you have to have two numbers with a comma and brackets, okay? It's not just asking for the roots here. You have to write them as proper coordinates. You won't get the full mark, I'm afraid. Part B says calculate the height, h, of the letter. Again, it's just asking you for what's the maximum height. It's asking you essentially to get the turning point, and then there's an extra wee bit to do, but I'll come back to that. So first thing I'm going to do is start beginning the turning point. Now you know that these roots here, you know that these roots occur at the numbers 2 and 8. Okay, so your maximum height will occur in the middle of 2 and 8. So the number that is in the middle of the 2 and 8 would be 3 away from each number, because the gap between 2 and 8 is 6, half of 6 is 3, 3 away from each of these numbers is 5. Alternatively, you can just do 2 plus 8 is 10, half it gives you 5. So I know the maximum height of this occurs when my x coordinate equals 5. So I'm going to sub in x equals 5 into my equation. So that gives me y equals 5 minus 8 in the first bracket and 2 minus 5 in the second bracket. Multiply this out, it gives me minus 3 and minus 3 again, which gives me y equals 9. So what I've worked out is essentially, let me move my diagram back. We have worked out that from here to here is 9. It then says from 0 down to the bottom of the letter A is 16. So the total height of the letter A is 9 above, 16 below. So the height is 9 plus 16, which is 25. I need to check for units. Oh, I never mentioned units. I am assuming it is probably going to be centimetres. So I'm just going to write whatever my units would be. That is a typo in my fault, I do apologise. It probably would be centimetres or millimetres. But when I've typed out the question, I've not put that in. That's quite bad of me. But let's look at another one. Right, so back to my things going in the air. So we talk about rockets, we talk about flares, we talk about kicking footballs. This one is a flare following a path. This time we're not setting the flare off from the ground. We're setting it off from maybe a certain building. And then it is launching and going into the sea. So perhaps what's happening is this is the person on your boat. Excuse my drawing of a boat. But this person is stood on top of the boat. And then they're firing the flare up into the air. And then it comes back down and lands into the sea. Alright? So that's why the parabola doesn't come right down the bottom. It says part A, calculate the time. There's no part A, it's just the whole question. Calculate the time taken for the flare to enter the sea. So the time taken is how far it is from 0 to here, which is your root. So we need to find our root again. Roots are when you put your y coordinate equal to 0, or in this case, your height is 0. So we are replacing h with 0. So we have 0 equals 48 plus 8t minus t squared. Right, I don't know if you've been taught how to factorise trinomials when there's a negative t squared. There is a little trick. You can just take everything to the other side of the equation and change your signs. So your t squared becomes positive, the 8t becomes negative, and the 48 also becomes negative. Essentially what you're doing is you have flipped the parabola. The roots will still be the same, but we need to watch and not use that any later in the equation. It's okay to do it to factorise to get the roots, but never use it for subbing in or anything at the end, or it'll give you like a negative when clearly our picture isn't a negative. So factorise this into two brackets. Numbers that multiply to 48 and add to 8, well, they are going to be, I've gone completely blank, 12 and 4. So, and it's going to be negative 12 and plus 4 to get the negative 8. Put them both equal to 0. And then solve them. And I apologise, sometimes I write this line, sometimes I don't. So we get t equals 12 and t equals minus 4. Now, one of these is no use to us. The minus 4 actually comes from this part of the diagram, which goes backwards. In this scenario, we can't have a negative time, so that's why there's nothing to that part of the picture. So what we do is we cross that one out and we say that that's impossible. You might want to write discard or not this one, something along those lines. And the conclusion says the time taken for flare to enter the sea, well, the time taken is 12 seconds for my conclusion. So I'm just going to write it takes 12 seconds. So there's your wee conclusion there. So again, another fancy way of asking for roots. Here is another one. It's a rocket being thrown into the air. Okay, but this one's got a little twist to it in part B. So part A, we've been given the equation and it says after how many seconds will the rocket first be at a height of 60? Right, so they're asking when is the height of 60. The word in here is first is quite interesting. Remember, at a height of 60, my rocket is going to have two answers. There's the height when it's going up and the height when it's going down. So when I come out with two answers, I'm going to take the lowest one because I'm looking for the first time where it reaches 60. So they've told us my height is 60, so I'm making my height 60. Plug this in. I have 60 equals 16t minus t squared. To me, this is looking like a trinomial. I've got a t squared, a t, and a number. I want everything to one side. So I'm going to move everything left. Sometimes I sing to my class and tell them what would Beyonce do, and they go to the left, to the left. So sometimes it helps. You might think I'm absolutely mad for just doing that. Anyway, everything to left-hand side. That becomes a positive t squared, a negative 16t. 60 is already there, so it stays as positive 60, and that equals 0. We're going to factorise this. We're looking for two numbers that multiply to 60 and add to 16. Well, they're 10 and 6. To make negative 16, they're both going to have to be negative. When we solve both of these, we get t equals 10 and t equals 6. And remember, we were looking for the first one, so we're not using that one. So for part A, after how many seconds will it first be at a height of 60? Our answer is 6 seconds. So that is part A. Part B, it says, will the rocket reach 70 metres? So they're asking us to find the maximum height. If I know the maximum height is over 70, it's not going to reach it. If I know the maximum height is under 70, it will reach it. So there's two ways to do this. You could go back to the beginning and find your roots and then the middle. But it's already led us in. It's already told us that this is 6 and this is 10. So I've come in a wee bit from each side here. This is symmetry, remember? So the middle of these two numbers will be what I can use for my t. So my t is going to be 8. So for part B, I'm subbing in t equals 8. Now, just to double check and show you that it is definitely, if I go and factorise this equation, you would have t bracket 16 minus t equals 0. That would give you t was 0 and 16, and the middle of 0 and 16 is also 8, right? So I didn't actually need to do that wee bit. So I'm plugging in t as 8 right into my equation. So my height will be 16 times 8 minus 8 squared. Right, 16 times 8 is 128. You can go do a sum at the side if you don't believe me. Take away 64. 128 take away 64 is 64 again. So my answer is getting there. It says, will the rocket reach 70 metres? So I've worked out that the maximum height is 64. Okay. 70 is greater than the maximum height. So, no, it won't reach. When you're doing a conclusion, please don't just say no. You have to justify your answer. So it won't reach 70 metres. Different things you can write is no, because that's 4 metres higher than the maximum height. I like to do a little inequality comparison. You can also write that the other way around, that 64 is less than 70. So just watch your conclusion on that one. Again, another way of asking you to get the maximum height or the turning point, but in context. My last one has been deemed as one of the worst questions at National 5. It made the papers because pupils hated it and went, we've never seen one like this before. However, the one I did a couple of slides ago was very similar, and it was in 2011. So if you'd done the 2011 paper, you would have seen a very similar question. So this one says, we've got a ball being kicked from a cliff top, and then this is it when it reaches the sea. Okay, so the sea level is at minus 70. And you can see that because I've given you the two pictures, okay? Find the height above the cliff top after 2 seconds. 1 mark means it's dead simple. T is 2 seconds. So I'm just asking to plug in t as 2. So we're doing 12 times 2, take away 5 times 2 squared. So we've got 24, take away 2 squared is 4. 4 times 5 is 20. 24 take away 20 is 4. So for part A, after 2 seconds of height is 4 metres in the air. So this is like probably up here. Oops, a daisy. Okay, so it would be up there. That's part A. Part B says, the sea is 17 metres below the cliff top, which is written here with a minus 17. After how many seconds will the ball hit the sea? So what they're doing is they're almost like creating a new quadratic, and we need to find what this value of t is. Now there would be another one over here if that picture went both ways. It's a bit like a roots question. However, just read the wording. After how many seconds will the ball hit the sea? They've told you the sea is 17 below cliff top. So our height is minus 17. So we are going to take our equation and we are going to replace our height with minus 17. So let's put this in. Minus 17 equals 12t minus 5t squared. I'm going to do my Beyonce and move everything to the left. Minus 5t squared becomes positive. 12t becomes negative. Minus 17 was already there, so it stays as minus 17. Now, my pupils freak out the minute they see a trinomial with a number at the front. There is no options here though. It's got to be a 5t and a t. To make multiply to 17, it's got to be 17 and 1. And I know that the 17 can't go there because then I would be doing 5 times 17, which is getting her close to 20. That's going to be far too big. So the 17 must be going here and the 1 will be going there. This isn't how I teach it though. I teach my pupils to do this at the side. And they go 5t and t, cross multiply. We put the 17 there and the 1 there. And we go 5 times 1 is 5, following the diagonal. T times 17 is 17. But to get minus 12, that must be negative 17. And then we circle our brackets. So it's minus 17 and plus 1. If you solve both of these, I'm going to do this one first because that's easier. That gives us t equals negative 1. And this one will give us 5t equals 17. T equals 17 over 5. Now this is one of those quadratic problems where one of the numbers doesn't make sense to us. We can't have a negative time. That was the part of the picture that we can't see, so you score that one out. And you can write impossible, you can write discard, ignore, anything along those lines that your teacher's told you. So the question says, after how many seconds will ball hit the sea? So my conclusion is, after 17 over 5 seconds. If you want to be really fancy, you could turn that into a decimal. I know that a fifth is 0.2, so 17 times 0.2 would be 3.4 seconds. But you would get away with writing 17 over 5, all right? So that is me done. Every kind of quadratic context problem question of the last 10 years or so. I hope this has helped. They are tricky, but please read the question. Have a wee bit of common sense and think, right, what are they asking me to sub in? They're either asking you to put it equal to 0 and get the roots, or they're asking you to replace the height with something and then put it equal and get the roots, or they're asking you to get the turning point, which comes from getting the roots. So at some point, you're factorising equal to 0. Getting your roots, finding the middle, subbing it in. Anyway, I hope this has helped. Thanks for watching. Bye-bye.